Hello and welcome. This is an introduction to a pollution and particulate capture system called Combustion Gases and Particulates Capture Process, using artificial intelligence to optimize the configuration for a more efficient pollution and particulate capture process to protect Earth's atmosphere and restore a harmonious balance between technological progress and the natural world environment and species therein, and averting the extinction of many rare plant life and organisms. Specifically, carbon dioxide, CO2, carbon monoxide, CO, nitrogen oxide, NO, nitrogen dioxide, NO2, and capture combustion byproducts processing, such as particulate capture. Particulate matter, also known as PM, is anything in the atmosphere that is not a gas. Hence, any particulate, material, chemical compounds, any of which may have varying levels of toxicity. The toxins may enter the bloodstreams and inadvertently be transported to various organs in the body, such as the heart, brain, kidney, lungs, digestive system, muscle tissue, central nervous system, lymphatic system. The United Kingdom is measuring fractions of PM when the particulate is less than 10 micrometers in diameter, PM10, and particulates less than 2.5 micrometers in diameter, PM2.5. In relation to the particulate matter, the Air Quality Standard Regulation 2010 states the following must not be exceeded in the United Kingdom: an annual average of 40 micrograms per cubic meter for PM10, a 24-hour average of 50 micrograms per cubic meter more than 35 times in a single year for PM10, an annual average of 20 micrograms per cubic meter for PM2.5. Fossil fuel combustion in cars, shipping, rail and gas turbines generate specifically carbon dioxide, CO2, and carbon monoxide, CO, which adds to the carbon in the atmosphere. In addition to nitrogen oxide, NO, nitrogen dioxide, NO2, there are other byproducts of combustion. It is advantageous to reduce the carbon, nitrogen dioxide, NO2, and particulates in fossil fuel combustion byproducts emitted to the atmosphere to reduce the effect of greenhouse gases in the atmosphere and reduce the effects of global warming. The fossil fuel combustion process requires the oxygen molecule. This inevitably has an effect on the oxygen density within the atmosphere. Reducing the levels of oxygen molecules in the upper atmosphere will have an impact on the Chapman cycle. This is an essential process in the process of reducing the ultraviolet radiation radiating through the Earth's atmosphere. More about the Chapman process in the next presentation.
I will explain the Chapman cycle. The 1930 British geophysicist Sidney Chapman explained how ultraviolet radiation is absorbed by the atmosphere and converted into heat. There are 4 distinct phases driven by the solar radiation. Phase 1. Photodissociation of oxygen. Ultraviolet radiation with a wavelength of less than 242 nanometers, UVB. These high-energy ultraviolet photons breaking the bonds in a normal oxygen molecule, O2, thus generating 2 highly reactive oxygen atoms. Hence, photon energy. E equals h nu, where h represents Planck's constant and nu represents the frequency of the radiation. O2 plus h nu to 2 highly reactive oxygen atoms. Phase 2. Ozone formation. Following on from the Phase 1 photodissociation of oxygen, the highly reactive oxygen atoms collided with the standard oxygen molecule, O2, to stabilize the newly formed ozone molecule. A further molecule such as nitrogen or oxygen absorbs the excess energy, thus stabilizing the combination into ozone, O3. O plus O2 plus M, O3 plus M. Phase 3. Ozone photodissociation. Ultraviolet radiation with the wavelengths of between 200 and 310 nanometers. UVC, UVB. Low-energy ultraviolet photons breaking the bonds in the ozone molecule. O3 breaks back down to a molecular oxygen, O2, and a single, free, highly reactive oxygen atom, O. O3 plus H nu, O2 plus O. Phase 4. Recombination. The free, highly reactive oxygen atoms, O, randomly collides with the ozone molecule, O3. The subsequent collision between the reactive oxygen atoms, O, breaks down the ozone molecule, O3, thus creating two standard oxygen molecules, O2. O plus O3, 2O2. Please be aware that the actual stratospheric ozone levels are lower than the Chapman's model.
Feel so good to me. Oh yeah, love her at first sight.